Here is 1.8, inverse functions. We're going to focus on finding inverses with relations and functions. So here's just a definition of what a relation is. A relation is a set of ordered pairs. X and Y is a relation. To find the inverse of a relation, you just flip-flop the X and Y, or interchange those X and Y values. So I have an example that we'll do together. So here's a set of ordered pairs in the blue. 1, 2, 2, 4, 3, 6, 4, 8. Question 1. Is this relation a function? If we were to go out and graph it, would it pass the vertical line test? Are there any repeated x's? No. So this passes the vertical line test. It is a function. There's no repeated x's. Next part of the question. What's the inverse of this relation? So we are going to interchange all of the ordered pairs. So what is the first ordered pair going to be then for 1, 2? 2, 1. What's the next ordered pair going to be then? 4, 2. What's the next ordered pair going to be? 6, 3. And the last ordered pair? 8, 4. Now look at that set of ordered pairs. Is that relation a function? It also is a function. It doesn't have any repeated x's. Now let's go out and graph these two relations. And we'll just connect the dots and make a line. So we'll graph the blue one first. So over 1, up 2, over 2, up 4, over 3, up 6, over 4, up 8. What is that making? We connect the points. We'll make a line. All right. Let's graph the red one. It's inverse. Over 2, up 1. Over 4, up 2. Over 6, up 3. Over 8, up 4. What is this making? A line again. There are the two relations graphed out. What we're going to be talking about later on today is if you have two relations or two functions, they're going to be, and they're inverses of each other, they're going to be symmetric about this line. The line is y equals x, where the y-intercept is 0, the slope is 1. So let's just graph this green line. So my y-intercept is 0, my slope is 1. So rise 1, run 1, rise 1, run 1, rise 1, run 1. Continue that. If I imagine folding my graph along that green dotted line, will the red and the blue go right on top of each other? Will they be symmetric about that line? Yes, they will every time. This is a relation, a set of ordered pairs. To find its inverse, you just flip-flop the terms. Every x becomes a y, every y becomes an x. Next, we're going to move on to a PowerPoint. This next PowerPoint, you're just going to listen and watch. And then we'll come back to the smartboard where we'll go back to doing some writing.